For those of you not in class today, let me show you how to solve these problems. So try them on your own first, but if you run into problems, use this video as a guide to help you out. If you still have problems, log into the classroom and ask for help, or come to the McCully one in the afternoon and ask for help. So the first one, we have two capacitors in series. So when your capacitors are in series, you want to add them like we do resistors in parallel. So you want to add the inverses. So you would do the total equals capacitor 1 and the inverse of capacitor 2. When you go through this, you should get a value that is lower than your smallest capacitor. Once you have that capacitance, that's the total capacitance, you can then find your total charge by using your formula for capacitors. Charge equals CV. Okay, so your total capacitance and then your battery will be your total voltage. That will give you your total charge. Once you have your total charge, you then focus on whichever capacitor they delineate. So for me, it's capacitor 2. That's the only one I got to do. I would do charge on capacitor 2 equals capacitance 2, voltage 2. I use the same charge that I had for the total. I use the value just of that capacitor, and I get my volts. That voltage should be less than 4.5. Well, it should be less than whatever your battery is. Finally, you get your energy. You would take your capacitance and your voltage just for that capacitor and plug them in. Once you have your energy, make sure you put it into microjoules because it's going to be a rather small answer. So hopefully you're able to work your way through and you understand that process. Okay, the next one is one where you're going to find capacitors in parallel. Parallel, I think, is much easier. They want the total energy stored in the capacitors. So what you can do is put 9 volts on each, or depending on what your battery is, the voltage of the battery should go with each. You can find the charge on each capacitor. You can find the energy on each capacitor. You have everything you need to do that. Once you got your energy on each capacitor, add the two energies together to get your total. And this time I think it will be most appropriate to put it in millijoules. Okay? The third one you're going to do will be a combination of both. It'll be a combo circuit. So again, you're looking for the total energy stored on the capacitors. The top one is easy because it's in a circuit all by itself. So it's going to be 18 volts. So to find the energy, you could just use energy equals 1/2 CV squared. You know the capacitance, you know the voltage, you got the energy on the top capacitor. To get the energy stored on these two, treat them as if they are a single capacitor. They are in series, so you want to add their inverses. Once you get that total capacitance, you can then find the energy on that combination of capacitors using your 1/2 CV. Use the total for the bottom branch. Use the 18 as your voltage, and you will get the total for the bottom. If you add the energy on the bottom and the energy on the top, you should get your total energy. Just make sure you put it in millijoules again, and you should be good. So I hope you're able to work through these, but if not, jump back on the Google Classroom or jump on Dora McCulley 1 and I will help you out.